let's start talking about slope fields. These are very, very simple, but a little bit tedious. But it's one way where, like, by brute force, you can figure out an idea of what the solutions for differential equations are. Slope fields represent the families of functions that solve the differential equation in question. So it'll give us a picture of what a bunch of solutions could look like depending on their initial conditions, but we'll get to initial conditions later on. So let's just draw a slope field. It literally is a graph of the little slope segments of functions. That's all it is. That's it. It's just the graph of the slopes. So let's take a look. So here we go. Draw the slope field for this differential equation. The derivative equals 2x plus y. What I did last time I taught this, I think I just plotted stuff in my head, plugged stuff in my head, and that was giving a lot of people trouble. So if you want to, you can write it out. I think you should do it in your head because it's super easy, but I guess when I'm explaining, I should probably write it out. All I'm going to do is plug in x and y values and find the slopes and draw little segments that represent those slopes. If I have a negative slope, I'll draw a negative slope. If I have a really large negative slope, I'll draw a really steep negative slope. It's very simple. All right, I've made a table, and really I'm just going to put a few points down. So like there, and there. So those ordered pairs, those have x and y coordinates, so I'm going to plug those in. Oh my goodness. So I have negative 1, 1, that's that point, and I'll figure out the slope for that. And then those ordered pairs are those points. I'm just putting them in my table. And now I put in those 3 points, and the last 3 points I put them in. So now, what am I going to do? I'm going to find dy dx by plugging him in. Look, because this is dy dx. Crazy, right? Crazy. This should be one of the easiest sections because I'm, in my opinion, well, maybe not, but this part at least should be just plug and chug. All we're doing is plugging in these x and y values to the x and y that's here. So let's just do that. 2 times negative 1 is negative 2 plus 1. Negative 2 plus 1 is negative 1. Amazing. This is crazy. That's amazing. That's amazing. So next, we plug in just the next one over there. Negative 1 times 2, that's negative 2. Plus 0, that's negative 2. Oh, very good, very good. This would be negative 3 because we plug in, you get a negative 2, and then you get a negative 1. Negative 2 minus 1 is negative 3. It's very simple. That's all we're doing. Hopefully, maybe positive, fill in the rest, see if you get the same as me. The next one, you plug it in, you get 1. What do you get off my face? All right, so I'm going to pause it and fill in the rest. So, now, hopefully those are right. I'm going to double check. Now I'm going to plot these slopes. What do you mean plot these slopes? What do you mean plot these slopes? Look, slope of negative 1, that's like down 1 over 1. I'm going to plot that slope on that spot, that coordinate. So I go to negative 1, 1, which is negative 1, 1. There it is. And I have a negative 1 slope, but I'm going to take that. Look, I mean, you just take that idea. It's like you're drawing a line right like that. That looks like a negative 1 slope because it would go through there. Okay. And then I go to negative 1, 0. Negative 1, 0. Negative 1, 0. That's that ordered pair. So to plot that one is negative 2. Well, that's like going down 2 over 1. So it should look something like that. So that's what I do. It's a little bit steeper, huh? Amazing. And then I go to negative 1, negative 1. Well, it's right there. And, negative 3. So that would be like down 3 over 1. that would look like that slope, a little bit steeper. I mean, it kind of looks the same steepness, but let's see if I can do it a little bit accurately. Something like that. Those are those slopes. Do you guys understand? I'm just plotting slopes on these coordinates. So let's just keep going. I'll just keep going, huh? 0, 1. That's 0, 1. That's that point. And I'm thinking positive 1. Ooh, positive 1. That would be like up 1 over 1. It would look like that. So maybe like that. Pretty close. Pretty close. And then Chili Klaus. What? 0, 0. That's right there. And I get a slope of 0. That's an easy one. I'll just do it like that. And then 0, -1. 0, -1. That's right there. And I plot this -1 slope. That would be like a -1. That would be like that line. So I make the same like that. Yes. And then I keep going. I just keep going. I just keep going, you know. So, yeah, what is next? What is next? Plug in 1, 1. And then that's a 3. Ooh, 3. So 1, 2, 3 over. And it looks like that slope. So I make same. It's a little bit like that. Looks like that maybe. I try to make it look like the proper slope. And then 1, 0. That's a slope of 2. So it'd be like up 2 over 1. So it would have that kind of slope. It's a little bit less slanted, and then 1, -1, that's a positive 1 slope. So I keep doing that. As up 1 over 1, that will look something like that, maybe a little bit less. Okay, and I would do that and fill out the whole entire graph here. I mean, you're not going to have to do that because it's on the computer, but that's how you do it. And I'm just going to fill out the rest, and maybe you should fill out the rest. I'm not going to write them all in the table. I'm going to do it in my head, because I'm a genius. I could do it in my head. So that's what I'm going to do. Actually, I want to say something. I found like a pattern that might be very useful. So I'm doing like columns at a time. So maybe this is something good to look at. So if I go in the for the x direction, -1, -2, -3. All right. So I have -3 here. So I'm plugging in a -3. That gives me -6, right? -3, 0, right? Sorry, -6, 0. No, -3, 0. That's what this point is. -3, 0. And that gives me a slope of -6. So really what I am imagining here is I'm imagining, let's do it in blue. So my slope would be so like from here up 1, 2, 3, 4, 5, 6. So I'd imagine these dots and over 1. So that slope that I'm talking about would be like that. Kind of. I missed though. Like that. It would be that steep. So what I'm really focusing on is that point. And when I draw the slope, I just imagine that I'm making one partial piece, just that piece of that red line that I just drew. So I do that. And then when I move up to here, watch what happens. I find a pattern. I mean, it's different for every one, but I find a pattern. Look, here when I have this, that's still the same x-coordinate. So I still get -6, but then I add 1. That's -5. So that would be 1, 2, 3, 4, 5 over 1. I'm still looking at the same point. Whoops. So, again, in my head, I'm drawing this line, but I only do a segment of it. And I'm still focusing on that point. Do you guys understand what I'm saying? You can't tell. And then I'm still focusing on that point, so I can draw that one, that one, that one. It's pointing towards that point the whole time. That one, and then that would be a slope of 0 up there. But I don't have to do those ones. Does that make sense? So I find a pattern. And then same if I go down. Here, I'd still get a -6 plus -1. That's -7. Well, 1, 2, 3, 4, 5, 6, 7 over 1. I'm still focusing on the same point. So I can do it kind of fast. And there we go. And I got my slope field like this. So that's what I'm doing. Hopefully that was helpful. And I'll keep going. Again, I'm just plugging in the x and y coordinates and getting the slope. It follows different patterns each time. So this one, it followed a different pattern. So I'm just doing columns at a time. Okay, all done. Notice that if I start at some place and I follow my slopes, like if I start here at that point, it looks like I can kind of like, it's like following a river. Oh, I have some kind of equation like that. That's a particular solution. If I started maybe here, it looks like there might be an asymptote. So this would go maybe down something like that. And yeah, if I started over here, what would happen? I'd go down, probably keep going, and then again go towards my... So these are a family of solutions that kind of look like this, right? Do you see all of that? All of those are different particular solutions to this differential equation. So it's a map for the solutions, but that's all I'm going to do because it takes so long to plot these, but hopefully you understand how to do it. You're honestly just plotting points and figure out the slope there, or plugging in points and figure out the slope there. This is a long video. I'm going to be done. Good day, sir. I said good day! Or madam.